Moving on to properties of rational exponents. Rational exponents have the exact same properties as regular exponents. So instead of adding integers together or whole numbers together, we want to add fractions. So problems we had before would be like x squared times x to the third. So you do x to the 2 plus 3, which would give you x to the fifth. Right, well now, we're going to have x to the 1/2 times x to the 1/3. So that means we're going to have to do x to the 1/2 plus 1/3. Right, to add fractions, we have to get a common denominator. Right, the common denominator between 2 and 3 would be 6. So to get to 6, I need to figure out what I multiply 2 by to get to 6. So I'm going to multiply by 3, top and bottom by 3. 3 times 1 would be 3. 3 times 2 would be 6. And then I have to figure out what do I multiply 3 by in this fraction. What do I multiply 3 by to get 6? That would be 2. I need to multiply the top and bottom by 2. 2 times 1 is 2. 3 times 2 is 6. They have a common denominator now, so you can just add your tops, leave the bottoms the same. 3 plus 2 would be 5. So 1/2 plus 1/3 would give you 5/6. Likewise, when you have power to a power, we've multiplied our exponents before. So here I have x to the third raised to the second power. So that means I'm going to do 3 times 2, which would give me x to the sixth. If we have fractions as exponents, you're going to do x to the 1/3 times 2. To make 2 fractions, you put it over 1. So anytime you have a whole number, to make it a fraction, put it over top of 1. And then when you multiply straight across. So 1 times 2 is 2. 3 times 1 is 3. For a couple more examples, just like we did before, if you have numbers out in front, you need to multiply those numbers. So here I have a 2, here I don't have a number, so it's understood 1. So I would do 2 times 1, which would be 2. Variable is x, and since x doesn't have an exponent here, so it's understood 1. So it would be 1 over 1 plus 3 over 2. Alright, so we need a common denominator between 1 and 2, which would be 2. So to get from 1 to 2, I have to multiply top and bottom by 2. 2 times 1 is 2. 2 times 1 is 2. And we need to change 3 over 2, since it already has a denominator of 2. So 2x is going to stay the same. 2 plus 3 would be 5 over 2. On the bottom one, number 2, I'm going to multiply 4 times 3. 4 times 3 would give me 12. And I'll do 4 over 5 plus 5 over 4. So I need to find a common denominator between 5 and 4, which would be 20. So to go from 5 to 20, I need to multiply top and bottom by 4. 4 times 4 is 16. To go from 4 to 20, I need to multiply by 5. 5 times 5 is 25. And then to clean that up, your 12x stays in front. 16 plus 25 is 41. It would be 41 over 20. Okay, I'll pause video and do this u-try. So the first thing you want to do on the u-try is multiply your 6 times 2, which would give you 12. And you have 1/2 plus 3 over 4. Common denominator between 2 and 4 would be 4. Okay, so to go from 2 to 4, you need to multiply top and bottom by 2. 2 times 1 would be 2. This fraction already has a denominator of 4, so it stays the same. So it stays as 3. Your 12x stays. 2 plus 3 would be 5, and you leave the 4 on the bottom. Some more examples for power to a power. You just multiply straight across, top by top, bottom by bottom. So in 3, you leave your x the same, and you multiply straight across. So 2 times 1 is 2, 3 times 2 is 6. Then we can reduce 2 over 6. We can divide both 2 and 6 by 2. 2 divided by 2 would be 1. 6 divided by 2 is 3. For the bottom one, once again, multiply straight across. 5 times 3 is 15. 9 times 5 is 45. And we can reduce. We can divide both of those by 5. 15 divided by 5 would be 3. 45 divided by 5 would be 9. And we can reduce that one again. 3 and 9 are divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So it reduces to x to the 1/3. Go ahead and pause and do this you try. So once again, you want to multiply straight across. 7 times 2 is 14. 3 times 5 is 15. You can't reduce 14 over 15. So you use the exact same properties of exponents that we have been using, just using them with fractions now.